Hello and welcome. Today I'd like to take a look at Ohm's Law. The write-up for this lab comes from our Physics Through Inquiry manual. To do the lab, we're going to need a few things. We're going to need an interface. We're going to need a voltage current sensor. We're using a charge-discharge board and an assortment of patch cords to put it all together. So let's do that. I'm going to go ahead and connect my voltage current sensor to my interface. And then I'm going to connect the voltage across the component that we're first interested in. That's the 10 ohm resistor on the board. So we'll just go ahead and put that in place. And then I'm going to be connecting in the switch here, which I'm going to put into the neutral position so that I don't have a complete circuit yet. And I want to do is connect the positive side of the battery to the positive side of the charge-discharge switch. I'm going to connect the negative side of my circuit to the negative side of my battery. And then I'm going to connect the negative side of my capacitor to the top of my resistor. Okay, so the only thing that remains to connect is the current sensor, because we're also looking at current at the same time. To do that, I'm going to go ahead and connect the negative side of my current sensor to the positive side of my capacitor, and the positive side of my current sensor to the middle of my switch here. Okay. So as you can see, once it comes together, it's a little bit like spaghetti. So it's nice to go through and do it one piece at a time and discuss with your students as you're going what they're supposed to be doing, like observing the voltage across a component or the current through the circuit. So we're ready to go here. I'm going to go ahead and flip the switch into the charge position, and that's going to charge up my capacitor. That's going to be the power supply for our circuit, and as it discharges, that voltage will change. And one of the reasons we do this lab this way is so that students can see that the Ohm's law, in this case, applies in a circuit where the voltage and current are continuously changing. Up until this point, they may have been doing labs where they're measuring discrete components and discrete voltages and currents in a static system. So we want to do something that had some change in it. So the setup is very simple. I'm going to go ahead and bring up voltage using the show path on my SPARK Science Learning System. And that gives me a voltage versus time graph. I'm going to change the axes from time to current. And that's going to give me a voltage versus current graph. And that's what we're interested in seeing. So we want to see how these things change together. I'm going to go ahead and put my switch back into the neutral position. And I'm going to start discharging. And then I'm going to start collecting data. And immediately you're going to see a graph of voltage versus current evolve over time. And it's going to start heading towards zero, of course, because it's discharging. And as it gets close to zero, we're going to go ahead and stop collecting data. And it will start slowing down a little bit as it starts getting closer to zero. And I'll hit stop here. And then the analysis is relatively simple. I'm going to go ahead and bring up a linear fit for this particular graph, because I'm interested in the slope of that line. And sure enough, I get a slope of 9.92, very close to the 10 ohms of the resistor, and well within the tolerance of that particular resistor. So, excellent results. To continue this lab, I'd go ahead and look at the same thing on a 33 ohm resistor, and then also on a light bulb to compare ohmic versus non-ohmic behavior. As you can see, relatively quick to set up. Good graph. We also have a SPARK lab for this lab on the device here. So whether you're using the paper manual or the SPARK lab, it proceeds in very much the same way. We hope you enjoy doing this with your students, and don't forget to practice safe science. Thank you.